Okay, so let's talk about three-dimensional surfaces. So up to this point, you're familiar with the two-dimensional space. So we know for a two-dimensional space, we have two axes. We have the x and a y, and we can represent a point or a line or any equation in two-dimensional space. We're familiar with that. But now, what about if you have three axes? Then we have the three-dimensional space. So this picture that you see on the left-hand side, here, the center of this point right here, that's what we're going to call the origin. Imagine corner of a room. That center is the origin. And this axis right here, that's coming out from the origin, this direction, this is your x-axis. And from the origin, this axis right here, it's what we're going to call the y-axis. And the axis that will go toward the ceiling, it's going to be our z-axis. So this right here is what we have right here. That's your xy plane. And then we have the z-axis going upward. Now we want to practice how to draw a specific surfaces. So for instance, we want to be able to sketch, let's say we want to sketch x equals 3. How would that look like in three-dimensional space? Well, in two-dimensional space, x equals 3 is just a line right here, a vertical line, passing through the point 3. But in three-dimensional space, it's actually going to be a plane. So check this out. So I'm going to draw my three-dimensional space. Here's our z-axis. Here's our x-axis. Here's our y-axis. So let's label them first, x, y, and z. So as you saw before, on xy plane is just a vertical line. So let's draw that vertical line at x equals 3. So let's suppose this is x equals 3. And then I'm going to draw that vertical line. So this is the line I'm looking at. And it extends forever at x equals 3. Now, y could be any value, z could be any value. So it's a plane that's going to go upward like this from here. Be something like this. So use your imagination to see it as well. But I'm going to try to show you with the best ability I have. So something like this. So it's just a plane at x equals 3. So that will be the picture of this. Now let's go ahead and draw y equals 1 in xyz plane. So here's your z-axis, here's your x-axis, and here's the y-axis. So let's label them so we're familiar with where they are. Y equals 1, we know in two-dimensional space. So if you were to draw just xy plane, y equals 1, that's just this line right here at 1, the horizontal line. Now in three-dimensional space, it's going to be a plane along y equals 1. So here's y equals 1. Let's suppose that's 1. And I'm going to have extend this as far as we want. And you see this is going to be parallel to the xz plane. So this is your xz plane. So this plane, y equals 1, it's going to be parallel to that. So it's gonna look something like this. Just extending it in both directions. And so this is the plane we're looking at when y is equal to 1. Let's go ahead and sketch z equals 2, which means x and y could be any value. So here's our three-dimensional space. And we label them. This is our x, this is our y, this is our z-axis. Z equals 2, so z equals 2 is, let's suppose it's up here. So down here are the negative z values. So I didn't label them previously, but if you do want to, you can. And here you have the negative x-axis, and here you have the negative y-axis. So you can label them if you wish to, but I'm going to go ahead and label z equals 2. So z equals 2 is perhaps up here. And we want a plane right through that point. So it's going to look something like this. So this plane, it's going to be parallel to the XY plane. So it's going to look something like this. Right, so it's going to be a plane that will look just like that. And we just continue this forever at z equals 2. So that will be the plane z equals 2. Now let's go ahead and try one more sketch. Let's sketch y equals x. How would that look like in three-dimensional space? So we know in 3D, in 2D, it's just a line y equals x. So it looks like this. That's in 2D. So this is our x, this is our y. But in three-dimensional space, it's going to look like a plane. So here's our axes. So x equals y. That means z could be any value. So let's suppose this is the line in y equals x in xy plane. So something like this. And then this plane is going to run parallel to the z-axis. So let's pull it up like that. So perhaps something like that, parallel to the z-axis. And you can extend it further this way as well and just make it parallel to the z-axis. So something like that. And then all of this. This is the plane y equals x. All right, so let's go ahead and sketch z equals y squared. So if you were to draw this in two-dimensional space in just yz plane, so this is y, this is z, so it's going to look like a parabola towards the z-axis, or something like this. So let me just, so let me try to draw it again. So it's a parabola that looks like this. And then now we want to put this in the XYZ plane. So here's how it's going to look like. So this is our z-axis. This is our x-axis. And here is our y-axis. So along the YZ plane, so this one right here, this is the YZ plane. So we saw that right up here, that it's a parabola. So I'm going to go ahead and draw that first, and then I'll show you the 3D image of that. So here's the parabola. So pretty much you take this parabola and you put it in the XYZ plane. So it's going to look like this. So here you go. Put the parabola right there. And then since x could be any value, x really doesn't come into the picture. So this parabola is going to extend along the x-axis. So I'm just going to make a lot of duplication of this picture and make it extend along the x-axis like that. So this is how the picture would appear in three-dimensional space. So you start to see it looks like a surface. More specifically, we actually call this a cylinder, parabolic cylinder. You can say that. So it's gonna look something like this. And it just keeps going this way forever and that way forever. So that's the picture of this equation. Let's go ahead and try this one. So here you have x squared plus y squared plus z squared is equal to 4. Now, how do we sketch this? Well, if you just ignore z, you have x squared plus y squared is equal to 4. We know in xy plane, that would just be a circle like that of radius 2. So this is an xy plane. Now, what we're doing is we're extending this into three-dimensional space. So that's where we have the z coming in. And it's going to look like a circle in three-dimensional space. But of course, we're going to call it a sphere. So it's going to look like this. So we have a circle. So you can extend the negative x-axis and the negative y-axis as well. So you know how to draw that circle. So it's going to look something like this. So in every direction, the radius is 2. And then you just fill in this like that to show that it is in 3-dimensional space. So something like this. So it's a sphere center at the origin, and in every direction you want to look at from, it looks like. All right, so now I want to show you all the surfaces that we did in actually a 3-dimensional space using this app, which does a really good job sketching them. So the first example we did was x equals 3, and remember that that was a plane at x equals 3 parallel to the YZ plane. So if you type in x equals 3, you will see that plane right here. So this is the plane that I try to show you drawing by hand. Again, this gives us really good perspective on how this looks like. So that's the plane right at x equals 3. So the red axis is the x-axis, the green is the y, and of course the blue is the z-axis. The second one we did earlier was y equals 1. So that was a line at y equals 1, and then if you extend it, it becomes a plane right at y equals 1. So it looks something like this. So here, so the green is the y-axis, and there you go, you have your y equals 1, and it extends in every direction at y equals 1. So that's the graph. And then the next example we did was z equals 2. So that's a plane at z equals 2 parallel to the xy plane. So here's how that looks like. So there is z equals 2. And if you just move this around, you'll see that that's the plane parallel to the xy plane. And the next example we did was y equals x. So that was a line in xy plane. And when you put this in 3D image, it becomes this plane that's parallel to the z-axis. So there is the z-axis, and here's the plane that's parallel to the z-axis. That's y equals x. And the next example we did was z equals y squared. So if you put z equals y squared, you get this parabolic looking surface along the x-axis. So that's what I try to show you by drawing, but hopefully this gives you a better perspective. The red is the x-axis, and this is a parabola opens along the x-axis and it extends forever in the x direction. And the last example we did was a sphere. So you had x squared plus y squared plus z squared equals to 4. So that was a sphere of radius 2. So that was the picture I tried to draw. All right, so I hope this helped you understand 3D images a little better.